All right, hi everybody. So thank you for the introduction. So I just want you to first imagine that you have a book report to do in a couple days. And so you rush off to your nearest bookstore and grab the last copy of the book and run back home, only to realize that you're missing 90% of the pages. So you have no choice but to try and figure out what the entire plot of the story was just with the pages that are in front of you. So hopefully this doesn't happen to anybody in this room, but that's similar to the kind of problem I deal with at my work. And instead of pages though, I work with fossils. And I got my line there. So I use fossils to try and reconstruct the hundreds of millions of years worth of story that happened on this planet. And so I'm what you call a paleontologist, and this is a photo taken nearly 15 years ago when I was 12 at my favorite place in the world, the American Museum of Natural History. And so this is my younger brother. He looks way happier to be there than me. And so paleontologists use fossils to try and figure out and understand more about the animals that lived and became extinct millions of years ago. But fossils only provide a small fraction of the story about how animals lived and how they looked. And that's because when an animal dies, the soft part of the body, like the skin, muscles, and organs, they decay away very quickly. And so what you're left with are, well, literally bare bones. And even these bones get picked up by predators, scavengers, and swept away by rivers and floods. So all these bones tend to become scattered around an area before they are buried underground and they begin fossils. And so what you often see when you're out looking for fossils are these fragments of bones. And so this is a video footage I took when I was out in Mongolia this past summer in the Gobi Desert. But sure, you occasionally find some of the spectacular fossils like this one, where you have a velociraptor and protoceratops that are locked in their fighting positions. But you're still missing a lot of information about, for example, their color, what they smell like, what the soft parts are like, and also how they moved. So paleontologists have a lot of limitations when trying to recreate how the dinosaurs looked and behaved when they were alive. But although limitations are almost always considered to be sort of a negative thing, I tend to disagree. So limitations like these types of limitations actually allow us or provide opportunities for us to be creative, original, and resourceful. So, and that's what I find really enjoyable about being a paleontologist and being a scientist in general. Alright, so one of the examples that I'm going to show you today is what my research group has been working on extensively, is to look at the story of how birds obtain their specialized brain for flying. So when you compare it to the brain, I'll walk over here, to a reptile to the left, both mammals and birds have bigger brains given their size. And so, especially in the regions that are linked to complex processing of sensory information like sight and smell, and also motor reflexes, so movement and motion. And so we think that the bigger brain in birds are closely associated with their ability to fly. So in order to trace back how this bigger brain or flight-ready brain evolved in birds, we have to look at their immediate precursors, or their ancestors. And so they turn out to be dinosaurs. And you can see from the diagram that actually all living birds today are technically dinosaurs. So in a couple of weeks, when you're enjoying your Thanksgiving turkey, you're actually eating and munching on dinosaurs, which is a pretty amazing fact. All right, so back to business. So when you're trying to study the brains of living animals, that's fairly straightforward. But what do? How do you study the brain of a dinosaur? You can't just grab a really well-preserved precious dinosaur skull, crack open it like a nut, and expect to find the brain in there. The brain doesn't get preserved. You can also use the space, the empty space that's inside the skull that used to house the brain, right? The brain base. But you also risk damaging the skull, precious dinosaur skull. So what do you do here? Well, we use a machine called CT scanner, or X-ray CT scanner, which sounds really cool, and it is. So it was first developed to look at the inside of the human body. So it's at hospitals. But we used a more powerful version of the scanner to take over 1,000 X-ray images of a single specimen, stack them together so you get a 3D model of a skull. And so this is sort of the end result. And what's amazing about this technology is that you can actually peer through the skull without damaging the skull. And by digitally filling in the empty space where the brain used to be, you can actually recreate the brain of dinosaurs. So we've been using it to look at the brains in both extinct dinosaurs and also living birds to try and reconstruct how the story of the flight-ready brain evolved. And so a recent study done by my good friend, Dr. Amy Balanoff, and in our research team, she found that the dinosaurs that are closely related to birds also have bigger brains for their size. So this means that having bigger brains is not a unique feature of the bird lineage. And so multiple dinosaur groups actually already had somewhat of a flight-ready brain. And what's also neat about these brain models is that you can use it beyond just for making exciting new scientific discoveries. So I have this odd-looking machine here, so who knows what this is? Yes? Yeah, so this is a 3D printer, and we've been using it to make models of these dinosaur brains, and I have one right here in my pocket. So not only do we have the technology to look through a skull without damaging it, you can actually create multiple copies of these rare specimens, including the brain, and share it and make it accessible and available to people all around the world, which is pretty neat. And so, talking about the brains, so I'm sure a lot of you have heard of the left versus the right brain, right? So left brain is supposed to be part of the brain that's linked to skills used in science, math, engineering, and the right brain is for sort of more artistic and creative skills. And so I think a lot of people tend to think that science is incompatible with this side of the brain, so creativity. But I think that's far from the truth. And a lot of studies, time and time again, have shown that this whole concept of left and right brain is not true. And so, this means that both sides of the brain are actually used to try and accomplish a lot of the tasks that you have to do in your life. So a scientist, for example, that needs to figure out a creative way of solving a scientific problem, I think is pretty much equivalent to the creative process that goes on in the head of a painter, for example, who needs to deal with, for example, who's limited by the size of the canvas or the material that he uses, or a composer who's limited by the notation and also the instruments that he wants to compose for. And finally, we have some dancers and choreographers who's limited by the size of the stage. And so all these limitations force us to harness our originality, creativity, imagination, and resourcefulness. And so one way I've been experimenting with new ideas is through what's on top of my head. I need like 4 hearts. So this is Google Glass, and I've been using it to make videos that help people experience what scientists see and what they do, and try to recreate the experience scientists have to other people. So I took this device with me to Mongolia, and I took a lot of videos. So what I want to do today is to show you a short clip to give you an idea of what it's like to be a paleontologist out in the field.
It's my first class time in Mongolia, and these are dinosaurs. And so here's one very complete one, and it's very oblong, and it's got some tiny granulated surfaces. So these are characteristics of the TEDx of overlap, which is a common dinosaur found here. So here's another half an egg. Some eggshells.
So you can see that these are not perfectly preserved eggs.
2 more on this side, 1 here, and 1 here. And I also found a 5th one while doing a little bit more.
Alright, so this is the type of videos that I'm producing in the Gobi Desert, and I have other ones that tell us a story about the culture in Mongolia. So subscribe to the Natural History Museum YouTube channel to check out more videos. But before I get off the stage, I wanted to say that if you were going to remember only 90% of my talk today, that you at least remember this one bit, that limitations are not necessarily bad things, and that they contain enormous power to spark creativity and originality so that you can make incredible discoveries in your life. Thank you.